Alright, welcome to part 2. Now we're going to take a look at the same problem here from number 2 in a different method. So what we're going to do here is I am going to look at instead of the derivative of secant, I'm going to look at the derivative of tangent. Well, the derivative of tangent is secant squared of x. So I have that if I just borrow, a couple of those right over here. And I'm going to rewrite this one as secant squared of x, or in this case secant squared of 3x, secant squared of 3x, and I still have that tangent of 3x dx. And now I'm going to use substitution again, but this time I'm going to let u equal the tangent of 3x. Its derivative, secant squared of 3x times 3, don't forget chain rule, dx, and I get dx equals du over 3 secant squared of 3x. And what we're going to should notice happening is the secant squareds, one of the secant squareds will cancel out. And when I rewrite my integral, I now have this secant squared of 3x times, remember this is u, and I got this du over 3. Now I do have a problem right here, and that's because, well, I still have the secant here, and I have this u. You can't have two different variables. That's later, multivariable. We're not ready for that yet. So what we're going to do is I'm going to replace this. Remember, I could rewrite secant squared of x. Go all the way up here to the top. Secant squared of x is just 1 plus tangent squared. So I'm going to rewrite this as 1 plus tangent squared of 3x times u du over 3. Now, why on earth would I do that? Well, recall, we said u is the tangent of 3x. I can rewrite this now as the integral of 1 plus u squared times u du over 3. And if I simplify this just a little bit more, I get this 1/3 on the outside. I get u plus u cubed du. And I can integrate that 1/3, and I'm going to get u squared over 2 plus u to the 4th over 4 plus c1. And I'm going to distribute here, and when we distribute, I'm also going to replace my u. We're going to get 1/6 u, which is the tangent squared of 3x here, plus 1/12 the tangent to the 4th of 3x, whoops, don't forget your plus c1. Or in this case, it really should be a c2, because we are distributing that 1/3 right there. So let's take a look at another problem that involves the same technique. Now notice I do get different answers, but they are the same. You can graph them, let the constant be 0, graph them both on a calculator. You'll see they both are actually the same graph. They probably differ by some trig identity out there if you want to prove it. Now, let's take a look at number 3 here. Now number 3, the reason why I showed that last technique is that's what we kind of have to do here for number 3 here. I know that the derivative of cotangent is negative cosecant squared of x. So I want to get that cosecant squared of x. So what are we going to do? Again, we're going to borrow from this 4. So I'm going to write this as cosecant squared of x, cosecant squared of x, cotangent to the 4th of x dx. And using our u substitution, let u equal the cotangent of x, du becomes negative cosecant squared of x dx. So dx becomes du over negative cosecant squared of x. And I can just plug that back in, and we get the following. And we're about to have some wonderful musically noise as I try to fix my room. So when I rewrite this, now don't forget one of the cosecant squareds will cancel. I still have that negative, bring it to the outside, and we're going to get cosecant squared of x times the u to the 4th du. And now again, I still have a problem. I don't like this cosecant squared, but remember our identity from the other side. I could write this. I could write this as just 1 plus the cotangent squared of x, u to the 4th, du. And recall, u equals the cotangent of x. So if I plug that in, we're going to get 1 plus u squared, u to the 4th, du. Remember, look, I'm just going to plug that in. And distributing, we get u to the 4th plus u to the 6th du. And if I integrate that, u to the 5th over 5 plus u to the 7th over 7 plus c1. And I am going to distribute, and at the same time I distribute, replace my u's. So I get negative cotangent to the 5th of x over 5 minus, cotangent to the 7th of x over 7 plus c2. I am distributing a negative, so I should call that c2 right there. Now, our last property we're going to talk about are those product to sum properties. I know these aren't never invoke good memories. There's 3 of them that you have to know right here. And that says that if you take the sine of a times the cosine of b, it becomes 1/2 the sine of a minus b plus the sine of a plus b. If you have sine a times sine b, remember where a does not equal b, very important, we get 1/2 the cosine of a minus b minus the cosine of a plus b. Cosine and sine are the same, they both involve cosine, except for the cosine of a cosine b, it's 1/2 cosine a minus b plus, instead of a minus up here, cosine a plus b. So you just have to know them. Because if you know them, they're really kind of easy. Now, for a problem like number 4 right here, this is what we have. Where we have our A and we have our B. They're clearly not the same, so I just have to find out which property I'm going to use. Now, recall, what would we do if they were the same? What if I did the sine of like 2x times the cosine of 2x? Well, that's easy. Since they're the same, we could just use substitution if we wanted to. Because the derivative of sine is cosine of 2x here, then they'll cancel out. That doesn't happen here. The derivative here is cosine of 5x, won't cancel with the cosine of 4x. So we have to use our product to sum here. So if I rewrite this, this is going to become 1/2. Remember, this says it's going to be the sine. My rule here says it's going to be the sine, and I write this as a sine of 5x minus 4x plus the sine of 5x plus 4x dx. Now I'm going to factor out the 1/2, and that's going to give me the antiderivative of, this becomes the sine of x plus the sine of 9x dx. And this I know. I'm going to get 1/2. The antiderivative sign is negative cosine of x. Same thing here. I'm going to get negative cosine of 9x, but remember, there's a u substitution here. I'm really going to divide by 9, because remember, du is 9 dx, so dx is du over 9. So I have to divide by 9, or write that as 1/9 plus c1. I can distribute. I get negative 1/2 cosine of x minus 1/18 cosine of 9x plus c2. And there's our final answer. Very easy to do. Now, some of you guys might be asking yourself, we have to do u substitution for this one, but could we use our product to sum? Absolutely. Watch what this one, with product to sum. If I integrate this, my first rule says it's cosine, it's sine, cosine. So I'm going to use my first rule. And it says it's going to be 1/2, factor out the 1/2. If I subtract the 2x minus the 2x, I'm going to get 0 plus, and then I'm going to add them, and I'm going to get 2x plus 2x dx. I factored out the 1/2. And if I try it here, I get the sine of 0 plus the sine of 4x. Now some of you guys are going to try to integrate the sine of 0. Don't. It's just 0. So when I integrate it, I'm going to get 1/2. This becomes a negative cosine of 4x. But don't forget, there's a u substitution here. So what we have to do is divide this all by 4 plus C1. We have to divide by 4 because of our U substitution. So we would get negative 1/8 cosine of 4x plus C1. So you don't have to use U substitution there if you don't want to, if you know these product of sum rules. Well, that's it. I hope you enjoyed as much as I have, and I will see you guys next time. Bye-bye.